Welcome all of you. Good morning. Today I would like to discuss about the transducers. So different transducers are available, and those are used for biomedical applications. So what kind of transducers can be used to measure the different physiological parameters or the biological signals? I would like to discuss about these things. Okay, so move on to the next slide. So actually, in medical instruments, uh, these are generally electronic devices. Okay, so they require an electrical signal as an input. Okay, so physical event of our body that represents a parameter which has a transducible property, and this is transformed into an electrical signal by some device or some process which is a transduction process. And that's why the transducer, for converting the physiological property into an electrical signal, which can be uh, an input to an instrument. Okay, so what is the transducer? And I think all of you are familiar with these two terms, transducers and sensors. So basically, transducer, that is a device uh, that converts a primary form of energy into other different energy from one energy form only for measurement purposes. Okay, so uh, it is an usual practice to convert all non-electrical phenomena of physiological events into an electrical quantities using this transducer in case of biomedical instrumentation. So numerous methods suitable to various applications have been developed by applying basic principle of physics, and the physiological variables occur in many forms such as the hydraulic pressures and flows, mechanical movements, temperature variations, different chemical reactions, etc. So basically, in biomedical instrumentation, the main concern is conversion of bioelectric signal into an electric signal. So here, the transducer, that is a component which has a non-electrical variable as its input and an electrical signal as its output. Now, to conduct its function properly, one or maybe more parameters of the electrical output signal in the form of voltages or current or frequency or pulse, that must be a non-ambiguous function of the non-electrical variables at the input. So ideally, the relationship between the input and output should be linear. And a linear relationship is not always possible, but the relationship between the input and output should follow some rules like logarithmic function or square law, etc. So as long as the uh, transaction function is non-ambiguous, it is possible to determine the magnitude of the input variable from the electrical output signal, at least in principle. So certain other variables may interface with this transaction process, such as the hysteresis error is there, the frequency response, and the baseline drift are there. So there are two different principles used to convert uh, non-electrical variables into electrical signals. One of these energy conversion transducers based on these principles are called the active transducers. All of you know about this. And the other principle involves the control of an excitation voltage or some modulation of a carrier signal. So these type of transducers are basically the passive transducers on this principle. So here the primary energy forms like mechanical, as I have told you earlier, the mechanical, thermal, electromagnetic, optical, or chemical, these are the primary energy forms which will be converted. And what is the sensor? So sensor, that is a device that detects a change in a physical stimulus and turns it into a signal which can be measured or recorded. Transducers for physiological variable measurements. So a variable which is any quantity whose value changes with time. Okay, and a variable associated with the physiological process of our body, that is known as a physiological variable. So physiological variables, they occur in many forms, like uh, ionic potential, or some mechanical movements, or hydraulic pressure, flows, and body temperatures. So different transducers are used for different physiological variables according to the principle. So now the classification of transducers, basically these are the classifications, like active and passive transducers are available, analog and digital transducers are available, primary, secondary transducers, and other is on the basis of the principle which can be used. So first of all, the active versus passive transducer. What is active transducers? They add the energy to the measurement environment as part of the measurement process, and it requires the external power supply, and like as for example strain gauge, potentiometer, etc. And passive transducers are those they don't need add the energy as part of the measurement process, but may remove energy in the operation. Okay, and they doesn't require any external power supply, like thermocouple, photovoltaic cell, etc. Analog and digital transducers are also available, like in analog transducer, the transducer which convert the input quantity into an analog output, which is a continuous function of time. And digital transducers are those which convert the input quantity into digital form, in the form of pulses. Next is the primary and secondary transducers. So what is primary transducer? So some transducers contain the mechanical as well as electrical device, and this mechanical device which converts the physical quantity to be measured into a mechanical signal, and such mechanical device are called as the primary transducer. So in case of secondary transducers, the electrical device that convert this mechanical signal into corresponding electrical signal, such electrical device is known as the secondary transducer. And based on the principle used, so these are the classification, like there are several transducers like capacitive transducer, inductive transducer, resistive transducer, electromagnetic, piezoelectric, photoconductive, photovoltaic, etc. Next is how can we, so different criteria is there to select a transducer, and what is the criteria? What is first criteria is this one: what is the physical quantity that is to be measured? Okay, so that is the first criteria. Second is which transducer principle can best be used to measure that particular quantity. Okay, you must identify this. So next is the what accuracy is required for that particular measurement, like fundamental transducer parameters must be defined, different physical conditions must be taken into consideration, uh, environmental conditions must be there, and the compatibility of the associated equipment, because you need to connect it with some recorded or measured device. Okay, so you must sure uh, the compatibility of that particular equipment with your transducer. The last is the reducing the total measurement error, and how? Using in place system calibration with corrections performed in the data reduction. And second is the artificially controlling the environment to minimize the possible errors. Okay, so these are the criteria to select a transducer. So let's start about the active transducers. So all physical principles that can be employed for converting non-electrical activity in active transducer, mm, but not all principles are of practical importance in the design of actual transducers, specifically for biomedical applications. So in active transducers, in some cases, the same transduction principle used to convert from a non-electrical form of energy, that can also be used in reverse direction to convert electrical energy to non-electrical forms. Okay, say a magnetic, like as for example, a magnetic loudspeaker can also be used in the opposite direction as a microphone. There are several names are there uh, used to refer to this same effect when used in opposite direction, because two applications were discovered by different persons. Okay, so here is a table, uh, few methods of energy conversion used in active transducers. So here is a table that so in this table, uh, which energy
Hello.
is
So
changed.
I'm sorry to hello.
Yes.
So I'm sorry to interrupt, but I think there are some people here in the meeting. They are not from our class. Like these people with roll number on their name. Then these four people are not from our class.
Is there anyone from EC? So EC students, please leave this class. Hello. Is there any EC student? If you are there, you must leave this class. Okay. So this is not your class. You must leave this meeting. Is there anyone else? Is it okay now?
Yes, sir. Yes, sir. Please continue.
Okay. Okay. Thank you. Okay. So here is a table. In this table, you can see that from one energy to another energy, this particular method can be, this particular device or effect can be used, which may be reversible or may not be reversible. So first is the magnetic induction. Okay, magnetic induction. So here mechanical energy that is transduced in electrical energy, and it is reversible. Okay, in this the same type of effect is for electrical induction purpose. Okay, and for thermoelectric, then piezoelectric, all these are in reversible form. But photoelectric or the LED or the electrical polarization or the, so these are not reversible. Okay, for microphone, loudspeaker, these are reversible. So in magnetic induction here, uh, linear movement of an electrical conductor in a magnetic field is there in such way that the magnetic flux through the conductor is charged. A voltage proportional to the rate of change of magnetic field is induced. Now, if a current is sent through the same conductor, a mechanical force is developed, which is the proportional to the current as well as with the magnetic field. Okay, and as a result, uh, so, so this result basically depends on the polarities of the voltage and the current on the electrical side, or the direction of force and motion on the mechanical side. That is the conversion from mechanical to electrical energy or vice versa. Okay, so all electrical motors, generators, solenoids, and loudspeakers are based on this magnetic induction principle. Okay, so one basic configuration is of transducer is here, that use the principle of magnetic induction for the measurement of rotary motion. Mm, it is given here. So the output voltage in each case, that is proportional to the linear or angular velocity. Okay, and the most important application of this type of mm, uh, method, this type of principle is in the to measure the heart sound microphones. It is used, or it is used in pulse transducers. It is used in electromagnetic blood flow meters everywhere. So magnetic induction, that has an electrostatic equivalent called electric induction. Okay, so condenser microphone based on this principle, that is not widely used due to its wide frequency response and high sensitivity, but that is the same principle, same type of principle has been incorporated into this. Okay, so move on to the next one, which is the thermoelectric effect. So all of you know about the thermocouple. You are, I think, you are all familiar with these terms: thermocouple, thermistor. So basically, two wires or two wires of different material, that is iron and copper. These are assume these are connected, so that they form a close conducting loop. Then a voltage proportional to this difference in temperature of the junction is developed, and the polarity depends on which of the junction is warmer. Okay, and so here is a thermocouple, the picture which you have seen on this slide. It's a thermocouple, and the sensitivity of a thermocouple is small and amounts to only 40 microvolts per degree centigrade for a copper constant and 53 for an iron constant pair. Okay, nickel and copper constant. So the thermocouple basically it measures the temperature difference between the two junctions. So one junction should be kept at 0 degree centigrade by putting the junction in ice bath. Frequently, instead of an ice bath for the reference junction, and electronic compensating circuit can be used. And the inconvenience of having this to make the whole circuit from the two metals used in the thermocouple can be overcome by using a double frequency junction that connects to the copper conductors in this case, which you can see in this picture. Okay, so due to their low sensitivity, thermocouples are not used in the measurement of physiological temperatures. uh, but the thermoelectric effect to convert from thermal to electrical energy is called uh, the basically Seebeck effect. So in the reverse direction, it is called the Peltier effect, where the flow of current causes the one junction to heat and the other to cool. And the Peltier effect is sometimes used to cool parts of any instruments. Okay. Next is the piezoelectric effect, and if you know that if pressure is applied to certain non-conductive material, so that a deformation takes place, a charge separation occurs in the materials, and an electric voltage that can be measured across the material. So here, suppose Vp, it is given, it is measured across the material, and the material can be crystals, quartz crystals, or a Rochelle salt, which have been cut into a certain angle with respect to the crystal axis. Okay, and these piezoelectric properties that can be introduced into wafers of barium titanate. Okay, those who have I think read the memes last sem, they can some idea they have some idea that piezoelectric properties that can be introduced into silicon wafer, okay, or a wafer of barium titanates. So here is an electrical equivalent circuit of a piezoelectric transducer. So here a voltage source having a voltage Vp that is proportional to applied mechanical force connected uh, in series with a capacitor, which represent the conductive plates separated by the insulating piezoelectric material. The capacitive properties of this piezoelectric transducer interacting with the input impedance of the amplifier to which they are connected, it affects the response of the transducer. Okay, so You can see it from this picture. And on the right hand side, different trace diagram is there. So basically the first trace 1 here, it shows the force applied, sorry, force applied to this transducer, which after time t, this is time t, okay, this is time t, is it is removed. So while the electric field generated by the piezoelectric effect and the internal transducer voltage, that is vp vp uh, that is in trace 2, that is generated, it follows due to the applied force, and the voltage va that is measured at the input of this amplifier circuit. It depends on the value of transducer capacitance as well as the input impedance. Okay. Now the capacitance C and the amplifier input impedance R are subject to the applied voltage VA for amplifier for the duration of time t. Now, if this product R into C is much longer than the duration time t, then the voltage division between these two, that can be neglected, and the measured voltage that can be considered proportional to the force applied. The same. Now, to meet this condition for a large value of t, the input impedance of the amplifier should be very large. Okay, it is greater than t. R into C is greater than t. As an alternative, capacitor may be connected in parallel with the amplifier input, and this increases the capacity of the amplifier, but it also decreases the sensitivity of the transducer. Okay, and in case of piezoelectric transducer, where the output voltage is quite high, this approach may be permissible. Now, if the in trace 3, if look at this diagram, if the product of resistance and capacitance R into C is much smaller than the T, the voltage at the amplifier input is proportional to the time derivative of the force at the transducer, or proportional to the rate of to the rate at which the applied force changes. And if the product R and C, which is same, is of the same order as T, the resulting voltage, that is a compromise between the extreme and extreme of two previous stresses. Okay, that is a compromise between these two traces, trace 2 and trace 3. Okay, as any mechanical input may contain various frequencies, a distortion of the waveform of this resulting signal that can be occur, and that can be occur if these relationships are not taken into account. Okay, the where it is applied. So basically, this piezoelectric principle, it is used in measurement of hot sound or other acoustical signals from within our body. And these piezoelectric transducers, these are used widely in ultrasonic instruments as transmitter and receiver of ultrasonic signals. So we will discuss it in details in later. Now coming to the passive transducers. So a DC, basically a DC excitation voltage or an AC carrier signal utilizes this principle of controlling the passive transducers. Okay, and it consists of a basically passive circuit element which changes its value as a function of the physical variable that is to be measured. Okay, So basically, the transducer, that is a part of circuit element, normally an arrangement like Wheatstone bridge, which is powered by an AC or DC excitation signal, and the voltage at the output reflects the physical variable. Okay, so there are only three passive circuit elements which can be utilized as passive transducer, namely resistors, capacitors, and inductors. Okay, and it may also be noted that that active components like transistors that can also occasionally be used, and the active and passive have different meaning, as I have told you earlier, in components and transducers. So passive transducers cannot be operated in the reverse direction, unlike active transducers. Okay. So passive transducers using resistive element. Passive transducers using resistive elements. So basically, resistive elements that changes its resistance as a function of a physical variable that can be used as a transducer for that particular variable. Okay. So in strain gauge, what is if an axial force that is applied to the element to cause it to stretch, its length increases by an amount, and this stretching causes the cross sectional area of that particular particular so that particular area to decrease. So either an increase in length or decrease in cross section area result in increase in resistance basically, and the ratio of the resulting resistance change, um, that is del r by r, to the change in length, that is del l by l, we know that it is called as gauge factor. Okay, so the strain gauge principle that can be utilized for transducers in a number of different ways. Okay, in the Marcari strain gauge, which is sometimes called as the Marcari strain gauge, named after its inverted the resistance material consisting of a column of Marcari enclosed in a piece of silicon rubber tubing. Okay, so they are used limited in the measurement of physiological variable due to the dimension of such gauge, and this type of gauge is used in lithosmography. Okay, in lithosmography, this type of gauge can be used. Okay, so this is the bonded strain gauge configuration. The next is the passive transducer using inductive elements. So the inductance of a coil that can be changed either by varying the physical dimension or by changing permeability of its magnetic core. Okay, so that core that how this permeability of magnetic core can be changed by moving that core, uh, having permeability higher than the air through the coil, and this arrangement is similar to that of inductive transducer. Okay, however, in this inductive transducer, the core, that is a permanent magnet which moved induces the voltage in the coil, and in this passive transducer, the core, which is made of a soft magnetic material, which changes the inductance of the coil when it is moved inside. Okay, and the inductance then can be measured by using an AC signal. So other type of passive transducer that involving inductance is the variable reluctance transducer, in which the core remains stationary, but the air gap in the magnetic path of the particular core is varied due to the change of the effective permeability. The same type of principle that can be used in active transducer, in which the magnetic path includes permanent magnet is used. So this change in inductance in this type of transducer is not related linearly to the displacement of the coil. Now this difficulty that is overcome in the linear using the linear variable differential transformer using LVDT. Okay, so it basically it consists of, what is that? Here is a diagram. So it consists of a transformer with one primary and two secondary windings, and the secondary windings are connected so that their induced voltage opposes each other. Okay, if the core is in this center position, then the voltage in the two secondary windings are equal in magnitude, and the resulting output voltage will be zero. Okay, and if the core is moved upward, if the core is moved upward, then the voltage in secondary one increases, while that in secondary 2 decreases. Okay, uh, the magnitude of that output voltage that changes with the amount of displacement of that core from its central position to the neutral position. Okay, and its phase with respect to the voltage at the primary winding, that depends on the direction of that particular displacement. Okay, and so basically the nonlinearities in this magnitude of voltages, it induced in the two output coils which compensate that each other, and the output voltage of the differential um, transducer is proportional to the basically uh, core movement. Okay, okay, so we have 1 minute to end this session. If it is ended, you have to rejoin using the same link to continue the second session. Okay, so next is the passive transducer using the capacitive element. So here a parallel plate capacitor, that can be, that the capacitance of that capacitor, that can be changed by varying the physical dimension of the plate structure, or by varying the dielectric constant of the medium between the capacitor plates. Okay, and both effects have mm, this capacitive effect, basically these are used in the design of different transducer of environment. So the last is the passive transducer using the active circuit elements. So active and passive, so this distinction can be used when the actually used in circuit, used for circuit elements, that is based on different principle than that which is used for transducers. So uh, active circuit elements are those which provide power gain for the signals, as in case of like transistors. Okay, and the active circuit elements are normally used in passive transducers. The application of this active circuit elements in passive transducer is in the area of photoelectric transducers, phototransistors. The efficiency of photodiode, that can be increased if we make a photo transistors. Uh, Another is using the photomultiplier, and it is used in Hall generator. Okay, where the semiconductor transducer element which provides an output voltage that is proportional to the both applied current and any magnetic field in which it is placed. Okay, so in this way, the active circuit elements that can be used to design the passive transducer. Next is the transducers for biomedical applications. So in biomedical applications, many variables of interest like pressure, fluid or gas flow, which cannot be measured by standard transducers, uh, that are converted to one of the variables for which basic transducers are available. Okay, and some basic transducers for biomedical applications are listed over here. For force, like physical variable force or pressure, Which type of transducer can be used? Either piezoelectric or strain gauge. Okay, so surface strain that can be measured by the strain gauge. Velocity can be measured by the magnetic induction transducer. Displacement can be given by this LVDT. Temperature, maybe thermistor, thermocouple. Light can be measured by photovoltaic cell or photoresistive element, or magnetic field that can be used by Hall effect transducer. So force transducer, so a basic design element for conversion of variables is the force bearing member. Okay, so the bending of the spring due to the force results in a surface strain, which can be measured by means of bonded strain gauge, as you can see in this picture. Okay, so measurement of the displacement voltage, that is done by using a differential transformer transducer, as I have told you earlier, that can be also used. So transducer for displacement, velocity and acceleration. So displacement, velocity and acceleration are linked with each other. If any one of these three variables that can be measured, it is possible, at least in principle, to obtain the other two variables. Okay, both operations can easily be performed by electronic methods operating on either analog or using some digital signals. Okay, uh, like transducer for displacement and velocity, these are readily available in the market. The principle listed over there, it requires that part of the transducers that can be attached to the body structure, whose displacement or velocity or acceleration that is to be measured, and uh, that a reference point is also be available. And this two conditions cannot always be met in the biomedical applications. Indirect methods sometimes that have to be used. Okay, another is contactless method, that for measuring the displacement is and velocity based on optical or magnetic principles are used also. So magnetic methods usually require that a small magnet or piece of metal that can be attached to the body structure. Okay, also ultrasonic methods can be used to measure this. Next is the pressure transducer. So pressure transducers are related to the force transducers also. So pressure transducers utilizing flat diagrams, flat diaphragms, normally have bonded or semiconductor strain gauge attached directly to the diaphragms. So flat or corrugated diaphragms have also occasionally been used in transducers, which employ this variable reluctance or variable capacitance principles. Okay, move on to the next slide, which is the pulse transducers. So basically, each time, so our heart muscles contacts, and when it contacts, the blood is injected from the ventricles. Okay, consequently, pulse pressure is transmitted through the circulatory system, and this pulse causes vessel wall displacement while traveling through the vessel. Okay, and this displacement that is measurable at various points of the peripheral uh, circulatory system. So the pulse sensing that can be done by placing fingertip over the radial artery in wrist or some other location where an artery is just below the spine. So there are three techniques to measure the pulse pressure. One is the photoelectric pulse transducer. Another is the piezoelectric arterial uh, pulse receptor, and another is the strain gauge pulse transducer. Okay, so in photoelectric pulse transducer, pulsating blood volume, it changes. So any changes in this blood volume that can be detected by this photoelectric method using photoregisters. Okay, there are two methods are available. One is the transmittance method and is the reflectance method. Okay, so in transmittance method, it has a miniature lamp and a photoregister mounted in an enclosure which files over the tip of any of our finger. So this is the finger, and below it the lamp is there, and over here the photoresistor. Okay, so light is transmitted through this fingertip of and the resistance of the photoresistor is determined by the amount of light reaching this photoresistor. Okay, so how it works? So basically the blood is forced to the extremities, and the amount of blood in finger which increases with each contraction of heart. Now this alter optical density and consequently the light transmission through the finger, which reduces, and accordingly the resistance of the photoresistor increases. Okay, so the photoresistor, that is a part of voltage divider circuit. Here it is connected, which produces a voltage, and this voltage varies with the amount of blood in the finger. Okay, and this voltage basically it follows the pulse pressure and its wave shape that can be uh, recorded or displayed in some oscilloscope. On right hand side, the reflectance method, here the photoresistor is placed adjacent to the lamp. So only a part of light rays emitted by this lamp and is reflected and scattered from the and skin and tissue also, that is made to fall on this photoregister. Okay, so here the blood saturation of the capillaries determines the quantity of light, how much light is reflected. Okay, and the resistance of this photoregister, uh, it varies due to the above condition. Okay, so the voltage across this photoregister basically, which is connected as a voltage divider, it varies in proportion to the volume, which changes the blood vessels of the body of the patient. Okay, so in this way the pulse transducer is work, and this type of technique is used, I think all of you nowadays, the pulse oximeter, that is also based on this type of uh, technology. Okay, a piezoelectric arterial pulse receptor. So second is this one, where it consists of piezoelectric crystals, it clamped in a sealed capsule which is subject to the displacement stress. So this displacement is basically transmitted to the crystal through a soft rubber diaphragm, and the pulse pressure waveform is recorded by connecting it to the ECG recorder. So when the volume of blood in the finger, it varies during the contraction, which cause changes in the size of the uh, finger, and these changes are basically transmitted as pressure variation in the air column inside the plastic tubing, which is enclosed into it, and at the end of this tube basically a piezoelectric transducer that is used to convert the pressure which will be uh, changed to a electrical signal. So this electrical signal is then amplified and displayed on some display device. The third is the strain gauge. strain gauge pulse transducer. So displacement of the vessel wall that is transferred to the semiconductor strain gauge by means of this filler pin and this leaf spring. Okay, so this is the strain gauge which is firmly attached to this lip spring on one side, and to filler pin on the other side of this slip. So one ring around the filler pin of the transducer helps in minimizing the interference caused by this unsteadiness of application of transducer to the subjects or the patient's skin. Okay, and basically it uses this structure. So this is connected to the some voltage divider circuit and some or some recorded device. So there are three types of pulse transducer or pulse sensors. Next is the respiration transducers. So here mm, tissues, basically it receives the oxygen and given array carbon dioxide in the respiration system. So the breathing action that is to be controlled by our by a muscular action causing some volume of lung to increase or decrease to achieve a precise and sensitive control of the content of the carbon dioxide in our arterial blood, which is a rhythmic action in normal case. Okay, so there are two types of transducers available for the measurement of this respiration. One is the strain gauge based chest transducer, another is the thermistor based transducer. Okay, so uh, in strain gauge type chest transducer, what happened? So thoracic volume that change is observed in respiratory cycle. All of you know that. So this is sensed by means of a displacement transducer incorporating a strain gauge. So an elastic band which holds this transducer around our chest, and the respiratory movements results in this resistance changes of strain gauge element, which is connected as one arm of our the Wheatstone bridge with this one, Wheatstone bridge circuit with this one, and the output voltage of that bridge varies with the chest expansion, which gives signals corresponding to that particular respiratory activity of the patient, of the subject. Okay. Second is the thermistor based transducer, where during respiration there is a difference in temperature of inspired and expired air. So this is sensed by using a thermistor placed in front of the nostrils using suitable holding device. And if the difference in temperature of outside air and that of expired air is small, thermistor can be initially heated to a suitable temperature. And this variation of its resistance in synchronization with this respiration rate, it's as a result of cooling effect of the air stream that can be detected. Okay, and actually this thermistor circuit that is connected to some voltage dividing circuit or in a bridge circuit, which unbalanced signal gives the respiratory signal, which must be recorded. Okay, and so flow transducers are also available. So in uh, transducers digital output also available. So here in case of flow transducers, the flow rate of different fluids or gas can be measured using the different methods are available. So this will be discussed later in the later chapter. And transducers with digital output is also there. Some uh, uh, utilizing the digital methods of processing of data, which requires that any data entered into the system be in digital rather than in analog form. Analog to digital converters that can be used to convert an analog transducer output into a digital form. Okay, and the transducer whose output is in digital form uses encoder. Okay, encoding discs or some rulers with digital pattern or photographically etched on glass plates can be used. So a light source and an array of photo detectors, usually made up of photodiodes or phototransducers, are used to obtain a digital signal in parallel format when that indicates the position of the encoding plate and thereby represents the displacement that can be measured. Okay, so these are the some basic idea about the transducers. Those can be used to uh, process any biological signals in biomedical applications. So that's all for today. If you have any queries, any doubts, you can ask me now.